Hello and welcome to HashiCorp Learn Labs with Consul. We're excited to be here with you all today. We have some great content to share. They're going to help level up your stack. My name is Eddie Rowe, and my friend here is Daniele Carcasole.
Good morning, everybody.
Good morning. We are a fusion of Texas and Italy that'll be presenting these topics today. We also have some wonderful TAs and chat moderators that are going to help enrich your experience by answering questions and getting your questions to us. Lastly, our code of conduct. Feel free to check out the website for the details. This equates to being a kind human, making sure that we're as inclusive as possible and respectful as possible. Feel free to reach out to chat if you have any questions. With that, I'd like to kick it off and hand it over to Daniele. Daniele, excited to hear your presentation today. Take it away.
Thank you, Eddie. Hello, everybody. I hope you are enjoying HashiConf. I hope you are as excited as I am for all the news that have been announced for Consul. Today, I'm here with Eddie to talk to you as Vault, as secret manager for Consul when deploying Consul on Kubernetes. So to deploy Consul in production, we need to be able to manage effectively secrets. But what secrets do you need to deploy Consul in production? Well, first, Consul clients, Consul agent use a gossip protocol to discover and communicate between them. So gossip protocol gets encrypted using the gossip encryption key. You need to be able to safely store and distribute that key across the agents. Next, if you are for the servers, but also if you're using service mesh, you need to be able to generate and distribute effectively and safely TLS certificates. And last but not least, if you want to use Consul Enterprise, then you will need to store and distribute the enterprise license to the Consul agents. If you are deploying Consul on Kubernetes, you have different options to provide these secrets to your Consul agents. First, the easiest one, put them in your configuration files. This seems like a very easy solution, but eventually it doesn't pay off very much because those secrets become like sensitive content. So you cannot store your configuration file in a public repository, or it's highly probable that those secrets get leaked. So the next step, the leveling up the security, people usually uses the Kubernetes secrets manager. While this solution solves the problem of leaking the secrets or the credentials, it still keeps one problem, that is having a secret sprawl across different Kubernetes clusters. If you want to deploy many Kubernetes clusters or Consul on many Kubernetes clusters, eventually you will have those secrets distributed, and figuring out where one secret is stored to either rotate or revoke them, it might get tedious or long. The one level up, there are specific software called secret manager software. And considering we are at HashiConf, when we say secret manager software in HashiCorp, we mean only one thing, Vault. Specifically for this workshop, we're going to use HCP Vault, just to show you that it's already possible to do complex integration between Consul and Vault, even in the managed instance. But all the things that we're saying today are also applicable to any Vault instance, even if you self-host, if you want to manually deploy it. Let's start with the architecture. The environment today is gonna be composed by a Vault cluster, in this case in HCP, and an AWS EKS cluster. The two clusters are made able to communicate by having a peering connection between the HVN, the HashiCorp Virtual Network, and the VPC network. This is the starting point. We already deployed this before the workshop, so to not lose time, but we prepared Terraform code for you in case you want to test this after the workshop on your own pace. Next, to be able to make Kubernetes nodes able to communicate with Vault without the needing to passing a token for Vault, we are going to use the Vault agent. For doing that, we are going to deploy, as the first step of this workshop, the Vault agent injector inside our Kubernetes cluster. In this way, the new nodes or the new pods that are going to be deployed in Kubernetes will be able to interact seamlessly with your Vault cluster. Next, that comes the important part. We talked about secrets, and we talked specifically about TLS certificates and the gossip encryption key and the license. We're going to store those secrets inside the Vault secret engines. We're going to use the KV secret engine for the gossip encryption key and the license. And we're going to use the PKI endpoints, the PKI secret engines, to make Consul able to generate certificates on the fly directly from Vault. Next, that's where the interaction between Kubernetes and Vault becomes interesting. We're going to configure Kubernetes authentication method. Kubernetes authentication method permits your Kubernetes workload, the pods, to identify themselves in Vault using the service account name they're running with. In this way, you can have an easy way to define categories, define different permissions for workload based on their service account name. Last, we defined some secrets. We identified blocks of workload in Kubernetes. We need to map those two objects with specific permission. So we are going to define the permission using policies, the standard Vault way to allow users or workload to access secrets, and we are going to map those permissions to the secrets using the roles. Once the configuration is in place, we're going to get a bit more in detail on which roles and policies we're going to create. But once the configuration is in place, then you can seamlessly deploy Consul, and Consul will get the secrets at startup directly from Vault. Once Consul is deployed, well, sky is the limit. Next step is going to be deploying your workload and leverage Consul and Vault playing together and without the need to worry about secrets to pass to your applications. So we mentioned that there is going to be some mapping between the secrets and the workload. Let's see in detail what we're going to do. So we start with the secrets. Specifically, secrets that we're going to use are going to be the gossip encryption key, the enterprise license, as mentioned, and then for the TLS, for securing communication across agents, Consul agents, and your workload. Well, we are going to need first a root CA to generate all the other certificates so to have a chain of trust. We will create that CA, we will generate a root certificate, and then we're going to create an endpoint to make that certificate generation accessible for servers. And then we are going to configure the endpoints for Consul Service Mesh. Then we're going to create 5 corresponding policies that are going to give us as well the gossip policies to the gossip encryption key, the enterprise license for the enterprise license, and we're going to create one policy for the servers. We mentioned that they need to first trust the chain of trust, so they will need access to the CA certificate, and they will need to be able to access the endpoint to generate their own certificates at startup. Next, we want to generate a policy for access to the root CA certificate. And last but not least, we need to be able to create the endpoint and generate the prerequisites for the service mesh to be effective. So we're going to create a policy for setting up that environment. And with the roles, we're going to then do the mapping I was talking about. And we're going to have 3 roles. One for Consul servers that are going to give access to the secrets as gossip policy and enterprise license, but also to be able to generate the certificates for the servers and set up the service mesh. For the clients, we will need a bit less permissions. They will still need to be able to access the gossip encryption and the license, but they will only need to be able to trust the chain of trust, so by accessing the root CA certificate, and they will be able to join using autoconfig the servers and the data center. Last but not least, again, not all your workload, especially if you're on the first phase, will be inside the service mesh. So you will need to be able to interact with the service mesh, considering that all the traffic in and out of the service mesh is protected by TLS. You will need to be able to trust that traffic. Hence, we need one last role to be able to access the root CA certificate. So this is the final picture. We're going to see this image again in the tutorial during the workshop. So, but this is just to give an idea of what the configuration needed to make this combination, this cooperation between Vault and Consul to work. We collected all this information and the steps that we're going to follow today in a tutorial that got published a couple of weeks ago. You can follow this link to access the tutorial if you want to follow with me during this presentation. Otherwise, feel free to access the workshop, the tutorial, and test these steps at your own pace. Okay, enough slides. I guess you want to see the thing in action. I'm going to pass to the demo part. But before that, I would like to ask Eddie if there is any initial question in the chat.
Yeah, great timing. We have a question. So why do you use the Kubernetes auth method if you already have Vault agents and can connect to Vault without the need for a token?
Yes, very good question. Well, as I mentioned, Kubernetes auth method provides us a very straightforward way to identify pods or any workload in the Kubernetes cluster by mapping the roles that we created with Kubernetes service account name. You are already defining service account names when you are deploying your Consul data center, and probably you're going to define them for your workload as well. This one gives you an instant mapping between the workload you are deploying and the possibility to access secrets in Vault. So this thing removes one layer of worrying in how to distribute secrets.
Awesome. That's some good level up. Thank you, Daniele.
Any other question? No, I guess that counts as a no. Let's move to the workshop then. I'm gonna exit the presentation. Oops, sorry. And let's move to the tutorial. So as mentioned, this one is already live. You can follow this live now, or you can go there at your own pace. But the things I wanted to notice, is the fact that this reproduces the same architecture we mentioned to you before. We are going to deploy all this during this workshop, but for now we have a starting point. We already deployed a Vault cluster and an AWS EKS. We can verify this. I already set up my environment to communicate with both the Kubernetes cluster and Vault. So we can check that with Vault first. We can see that the Vault cluster is up, is initialized, and is not sealed. We actually also have the UI up. Next, we will see the Kubernetes. Sorry. We're going to retrieve all the pods, and we can see that we have a Kubernetes cluster with 3 nodes and the rest of Kate's machinery behind. The tutorial provides you all the prerequisites you need for executing the commands, but they can be summarized to, well, you need an AWS account, you need an ACP account, you can get a free trial if you want, and then some tools for interacting with Kubernetes. So Helm for our deployment, kubectl for managing the cluster, Git and JQ to, well, use retrieve the code and manipulate some output. And last but not least, Terraform to deploy the prerequisites and Vault CLI to interact with Vault. As mentioned, we created a repository for this. You can retrieve the code. I'm going to skip through this section because we already did all these steps. We verified that the Kubernetes cluster is up. And we also set up the environment to interact with Vault. When we're going to try this at home, you will have to export some values, namely the tokens and the token and the address for Vault to communicate with the Vault CLI, and the Vault private address that we're going to use for some configuration later, and the namespace. So let's start with the actual steps that we're going to do today. We mentioned we want to install Vault Agent Injector inside your Kubernetes cluster to permit the seamless authentication between Kubernetes objects and Vault. To do so, we're going to use the official Vault Helm chart, and we're going to generate the configuration this way. We're going to just specify the injector configuration corresponding to the Vault remote address. Let's copy this configuration and create the file. Once you created it, well, make sure that the address got correctly expanded inside the file you create. You can see that this is the case. So now we are all set for the configuration. We can actually deploy the Vault Agent Injector. I mentioned we're going to use the official Helm chart for Vault. So let's make sure that we add the repository and that we update the repository. I already added, so it was pretty quick, but it's not going to take you more than a couple of minutes. Finally, we can pass to the installation. As you can see, we are passing the configuration file we just created, and we are specifying the latest version for HashiCorp Vault Helm chart. This is usually pretty quick. It doesn't take more than 1 or 2 minutes. Let's see if this is the case. There we go. So now we have Vault Agent Injector installed in our Kubernetes cluster. We can start configuring Vault. We're going to start with storing the secrets. So first one, you want to store the gossip encryption key in Vault. For doing so, we need to use the key value store. So first, we're going to enable it. And next, we are going to store the key inside Vault, and we are going to generate it on the fly. Consul provides you an easy command to generate the gossip encryption key. We're just going to pipe it in and use it to generate this secret on the fly, so that we don't have it stored anywhere, basically. Well, except in Vault, of course. For this workshop, we're going to skip the Consul Enterprise steps. But if you are in Enterprise, we provided steps there, so that are specifically related to passing the license. Next, we are going to start enabling the PKI secret engines for the certificate generation. So we're going to first enable the one for the main TLS communication across servers. Is it possible to tune it for a maximum TTL for the certificates? In this case, we're using like a very long TTL, but you can tune it to accommodate your internal policies. This step is just to show you that you can accommodate the TTL according to your internal policies. And then the final step for this is going to actually create the root CA certificate that then is going to be used by basically every actor in the service mesh and in the Consul data center. This, you should receive an output like this. This is the certificate that got generated. We mentioned that servers will need to be able to generate certificates on the fly for joining the data center. So we're going to just create a role for Consul servers to enable them to generate those certificates. And we are going to enable the connect root that is going to be the root certification authority for the Consul service mesh. The Consul service mesh requires more than just this, but all the steps can be automated by Consul. So the minimum amount of effort we need is just this: enable the endpoint, the connect root endpoint, and then we're going to provide permission to Consul to actually generate all the remaining parts by itself at startup. So now that the secrets are in place and we created all the endpoints needed for future use, now we pass to the configuration of Kubernetes authentication. So first, as any plugin in Vault, we need to enable it. So we're going to enable the authentication method Kubernetes. And the next step is to configure them. So to configure it, we will need a few objects, the JWT token, we will need a CA certificate for Kubernetes, and we're going to need the Kubernetes address for Vault to be able to access it. So we're going to store this information that we're going to retrieve from kubectl inside variables, just for simplicity, to not have a command that's too long. But you can actually like strip this in a way that so that the variables are not remaining in memory, if you wish. And with all this information, we will now do the important part, that is actually the configuration. As you can see, the configuration passes all the variables we just created. And success, we configure Kubernetes authentication. Let's just make sure that the configuration got written inside Vault, just for the sake of being pedantic. And as you can see, the configuration changed in Vault. So now we have the secrets in place. Kubernetes and Vault are able to communicate. Well, we need that now to actually fine-tune those permissions. We will start by generating the policies. We mentioned we needed a gossip policy for the gossip encryption key, so we're going to create that. And the policies is pretty self-explanatory, but we have documentation for this if you want to later go on and check which permission we're actually assigning. Next is to generate a policy for Consul servers that will give it access to all the endpoints needed for generating the certificates. We're going to create a policy for the root CA certificate. And this one, I mentioned to you that Consul will manage a lot of stuff in the background that starts up to configure the service mesh endpoints. Those are the permission needed for Consul to automatically set up the PKI engines on your behalf. There are more manual configuration where you could configure them manually, but we are not interested in that because we are trying to reduce complexity in configuration rather than pushing you to have it manual. So this one will provide necessary permission to Consul to set the service mesh up. Oh, sorry, So those are all the policies. Next, let's map those policies to roles. We will start, the roles are going to be the first one we're going to configure is Consul server. You can see that we are going to define the role using the service account names in Kubernetes. So we are binding this role to the Consul-server service account name and in the, with the namespace Consul in Kubernetes. And those are the policies we are defining for the role. The same goes for the client. As you can see, the service account name changes to map clients, and the policies change to reflect the actual permission we want to provide. And the last one is the one that allows all the workload to somehow be able to trust the service mesh traffic. So it's we're binding it to all service account names. Okay, this ends the configuration. There are like a few steps. It might seem a bit long at the beginning, but imagine that those are like all the configuration needed to make sure that from this moment on, all your new Consul agents, all your workload is going to be able to be deployed in the service mesh without the need to pass secrets. All the new actors in the workload, we will be able to retrieve the secrets automatically or generate them automatically involved. This is a summary of the configuration we just created. What's left now is just to go ahead, deploy Consul and verify that Consul is being deployed properly. We are gonna still use the Helm chart. We need to configure our Helm chart. The Git repository provides you with an example Consul values. We suggest you to use that rather than the data you find in the tutorial, simply because the tutorial doesn't contain the full configuration. But let's go edit the Consul values in it. You can see that the main interesting block is this Vault configuration that defines how secrets backend are managed. We're telling Consul that basically we're going to use Vault for managing our secrets. We are defining the server role and the client role so that they will map. And the only configuration needed is to actually substitute this Vault private address with our actual Vault private address. Let's actually retrieve the address. So, we have it. If you remember, we stored it in a variable. We can copy this and then go back to, go back to our editor. We can remove this, add address, and save. So once the configuration is in place, next we just need to install Consul. You see, we install Consul in its own namespace. We use the configuration we just defined, and we use the latest version of the Helm chart. The deployment, as well as the Vault one, that usually doesn't require much time. We should be out of it in a couple of minutes, but let's see the output. It seems blocked, but I assure you that it's gonna pop out some output in a second.
Daniele, do you
Yes.
have a moment for a question right now?
Yes, that's a right moment, actually. Yes, go on.
Perfect, great. Yeah, we have a question that floated up. Why do you have two separate roles that contain the CA policy to access the root CA certificate?
Oh, yes, that's a good question. That seems like a bit confusing, but what I tried to mention in the previous slides is the fact that there are different actors that need to access, that need to be able to trust the traffic. One is the Consul clients and servers that need to be able to actually be part of the data center. So the Consul client will use that for the joining the Consul service mesh. So they need that CA certificate. But even other external traffic that you don't want to provide with other secrets, like accessing the gossip encryption key or the enterprise license, they might still need to be able to access or trust the traffic in the service mesh. And for doing that, the root CA certificate is still the one that starts the chain of trust. So that is needed not just for Consul, but even for other workload or clients.
Awesome.
Okay.
Thank you.
And apparently that was the right timing. We actually completed the installation. Let's check. So we are all set. All the steps are needed. Now we have Consul data center deployed, but to not just trust this written output, let's go check if Consul is actually up and running. Let's see if the different things are reflected in all the even involved. Oh, something happened to the.
It's like the
yes, that got skewed in something, but we can still copy this. Oh, that was a good catch. So Consul, the moment it gets deployed, it gets registered as a service in Kubernetes, and we get an actual external address to be able to access it. Let's go check Consul UI. Oh, sorry. This I think is HTTPS. Okay, this is going to happen to you too. We created the certification authority for being self-signed. Those are not public certificates, so that's what we get warned about. We want to accept and trust Consul certificate to access it. That's also why we want to access the root CA certificate, so that we can use that to embed it and make it trust by our browser, so we don't need to actually constantly accept the risk and continue in our browser. So we can see that Consul is up. There are some services already registered. We already deployed in the chart the ingress gateway and the terminating gateway, and we are also able to see the Vault agent injector that was registered via Kubernetes, because Kubernetes is aware of it. We are syncing the services. Interesting might be to go visualize what Vault is on its side, and we're going to check specifically the number of clients that are now connected to Vault. You can see that before I refreshed, there was only one client, and now that we deployed the Consul data center with all the clients and the gateway, now the number of Vault clients raised to 8. This means that all is working. The pods are actually interacting with Vault, and Vault is able to recognize them as clients.
That's awesome. Daniele, thank you so much. Is there anything you'd like to touch on? We're getting close to time here.
No, I guess that's that was the main part. Do you have are there any other question, or maybe we can skip questions to the next to the end of the workshop?
No worries. Our TAs have done a great job facilitating the questions in chat. So please feel free to ask more questions there. We can handle those questions there. So we're good on questions right now.
Okay, so I guess that's it. I'll pass it to you for the second part.
Awesome. Yeah, thank you so much, Daniele. That was great. Martin, production, if you'd like to change on over, we can switch to my screen.
Yeah, I guess we are there.
Excellent.
Perfect.
Cool, Daniele. Thank you so much. That was awesome. So yeah, hi guys, it's me, Eddie again. This presentation, the two-parter here for Learn Labs is this presentation is focused on giving you the ability to create a fully managed service mesh using Consul API Gateway as your ingress controller, HCP Consul as your fully managed service mesh, and Kubernetes in the cloud. So using this methodology lets you offload the overhead of operating a service mesh so you can focus on building and scaling your applications. A little fun fact for you. 90% of Kubernetes users leverage cloud managed services. This came from Datadog, this container report that was updated in October of 2021. This is based on usage data from thousands of companies in more than 1.5 billion containers across EKS, AKS, and GKE. If you've ever attempted to set up Kubernetes on bare metal, I'm sure you can understand why. Cloud managed services like EKS and HCP give you greater scalability, more flexibility, and quicker time to release, all at a reduced cost. With that pattern in mind, our objective today is to show you a simplified traffic ingress into a cloud managed service mesh using these technologies. In this presentation, we're going to explore this pattern on an environment that uses HCP Consul to control the service mesh and EKS as the cloud Kubernetes service. On top of this infrastructure, we'll deploy Consul API Gateway to facilitate north-south traffic ingress into two distinct Kubernetes services within your service mesh. So now that you know where we're going, this is essentially how we're going to get there. To guide you through the build, we're going to break down each component of this environment to discuss more details around how it works. The resources we're going to use for this presentation live permanently on our Learn site here, similar to Daniele's as well. Feel free to head straight there to start spinning up some resources yourself, or save the link in a tab if you'd like to check it out in your own time later on. I'm totally biased because I helped write this guide, but I think it does a great job at helping you get your hands on these features in a quick, easy to use way. So let's get started by checking out the architecture diagram for this environment. This diagram shows the demo environment we're going to build out, and we'll use this artifact throughout the presentation as a "we are here" reference as we zoom in on some of the components within. A brief overview of this, the traffic flow. The outer boundary symbolizes the EKS environment that's at Amazon. Within that, this pink area symbolizes the Consul service mesh managed by HCP. The boxes within the service mesh are the example services we'll use to demonstrate some of the Consul API Gateway's capabilities, including ingress for a microservices application and service load balancing. The Consul API Gateway serves, the service itself facilitates ingress from external clients to the respective services within the mesh. And so let's zoom in on the API Gateway piece now. So these are some details on how you configure the Consul API Gateway to handle traffic ingress into the service mesh. There's essentially two configuration files that configure the Consul API Gateway. There's the gateway and the routes. The gateway component is the main Kubernetes infrastructure component that links all other configuration information together, including the routes. It defines a listener for HTTP, HTTPS, or TCP traffic, depending on where you configure. In this demo, we're going to define an HTTP listener for the sake of simplicity, but in a production cluster, you can easily use cert manager with Let's Encrypt or Vault to easily generate and configure certificates for HTTPS gateway listeners here in the gateway configuration file. So routes attached to a gateway, like I briefly touched on, they define a list of rules to perform actions against matching traffic requests in. An example of a rule would be to listen for requests to the certain path, like example.com/echo, and then load balance those requests between two Kubernetes services, like Echo 1 and Echo 2 in this example, based on a weighted value. So let's zoom in on how traffic moves through the cluster. So a client request comes in, and that can be HTTP, HTTPS, or TCP. It comes into the Kubernetes cluster from outside. It's then handled by the Consul API Gateway, which is the infrastructure component, based on the configuration that you set in the gateway.yaml file. It's then routed to the HTTP routes that you define in your routes.yaml file. And then that traffic is sent to the respective Kubernetes service, and finally, the underlying pods that serve that request. And that's a complete traffic ingress journey into the service mesh. The final component I'd like to touch on before we check out the demo is HCP Consul. So HCP Consul, I want to zoom in on this piece here. HCP Consul is, this is the high-level networking diagram for HCP Consul. It shows how a peering connection is essentially what enables your HCP Consul and Amazon EKS resources to communicate with each other. So like Daniele touched on as well, this connection allows HTTP console to effectively manage your EKS service mesh. The resources exist in the same data center region, in this case, US East 1, to ensure the lowest possible latency. So running console on HTTP reduces your operational overhead with a lot of features focused on security and resilience. And a lot of the best practices about console are incorporated by default. So you spend less time configuring console and more time focused on your applications. Feel free to check out our docs and tutorials on HTTP to learn more about how HTTP makes your service mesh life a little easier. And we'll send those links out and touch on those later as well. Okay, so we've touched on each component of this cloud managed environment. Now we're going to check it out in action. But before we do, I'd like to open up the floor to any questions right now. Do we have any?
Yes, so there is one that seems like actually a very interesting one. Say, the pattern seems interesting, but then could this pattern be deployed in any cloud provider? Or do I have like any limitation for this?
Yeah, good question. So yes, basically Consul API Gateway and this pattern in the console service mesh can be configured on any cloud provider with managed Kubernetes. However, HTTP console, it supports 2 providers today. It supports AWS, and we just launched HTTP Azure. So if you're using AWS or Azure, everything shown here will work in your environment. If you're using GKE or another provider, the cloud managed provider, you can accomplish the same traffic ingress pattern seen here today with self-managed console. So you can do the same, accomplish the same objective with that.
Okay, that's clear. Thanks. I guess we don't have any other question for now. Let's move to the demo and then see.
Okay, great. Thank you. Okay, so here's our architecture diagram once again that you're getting familiar with as a reference. We're going to start out by reviewing the API gateway configuration. And for that, I'm going to take this out of full screen, and I'm going to open up Visual Studio Code. So let's hop over to this code. All right, so we talked about it in the we talked about it briefly. Let's see if I can make this a little larger. Doesn't look like it wants to let me. I'll make it full screen. All right, yeah, we talked about this briefly. This is a typical Consul API Gateway file. This one's pretty bare bones because it's just HTTP. In this, you'll notice a few different configuration points. We have HTTP that we're configured for. This is going to be the expected traffic that comes through from external traffic. We have it set up for port 80, just to listen on a typical port for that traffic to come in. But this is, all of these options are configurable. And we allowed the different routes. We allow routes from the same namespace in itself. Now, if you were using something like HTTPS in this configuration file, you would have some other stanzas below this that would configure that certificate. So that way your listener that sits here is configured with your SSL certificate. So this is the gateway file. There's a lot more detail about this in our docs, which we'll share later for configuration. The second configuration file is our routes file. So this is the example route file that we use in this instance. And a few things, I want to call out a few things here. This right here, this parent refs piece right here, this is what attaches. This is how it knows which API gateway to attach to. So this is the name of our API gateway in the configuration file we looked at before this, the gateway file. So that's very important. And then down here, this is where you define rules. In this case, we have a rule based on a path. That's a path prefix, with that path prefix being /echo. So any request that comes in to your environment with the DNS that we'll see /echo is going to be routed to these reference services here. This is where you can define the reference services like, in this case, we have 2 services that are Echo 1 and Echo 2, each listening on different ports in the respective containers. And then we have a weighted value system. There's other options here for doing this kind of routing. There's different kinds of like blue-green deployments. You can look for tags. You can look for HTTP headers. In this case, we're going to do a weighted value for the example, and that's a 50% chance of a client request being routed to Echo 1 or Echo 2. You can define multiple HTTP routes here. The other one that we have set up is for our microservices application, HashiCorp, which will go to just the standard slash path here. But you'll notice a similar configuration. We have it attached to the API gateway. Cat prefix is the type that we're looking for matching. And this is routed to a different service in Kubernetes, Nginx on port 80, which is the front-end ingress into the microservices application. All right, so let's run a few commands. So before this, we've deployed already our services and our infrastructure components. What we haven't done yet is we haven't deployed the API gateway. So we're going to go ahead and deploy that now from the configuration file that we just took a look at. So there it is. The gateway is created. That's going to be spinning up in the Kubernetes cluster now. Let's make this a little larger. All right, the second component is the routes, like we just saw as well. So we're going to attach these routes, essentially, to the API gateway. Cool, looks like that finished. Let's take a look at the pods real quick to see what's running on our cluster. We have our services here. We have our console components here. And then the ones that we just deployed are the API gateway with its routes. All right, so now I want to take this opportunity to hop over to Chrome because we want to go check out what's going on in console and see what's happening in the console UI. However, like I touched on a little bit earlier, the console UI is secure by default. So here's our console UI. We aren't able to see any of the services or nodes or values because we need to first get an ACL token. So I'm at portal.hashicorp.com right now. This is the portal website into the HCP UI. I'm going to change over to our shared org, away from my personal org here. I'm going to go over to console. I'm going to go to my cluster, which is right here. And then up in the top right, we have a few options. We have manage for editing your cluster, expanding the size, or updating the version. We also have access console here. So there's a couple values. There's this public URL that I'm going to grab, and I'm going to stick here. This is going to take me to my console UI. And then there's another one that's generate an admin token. And so this is an ACL token. It's going to help me get into my console cluster. That's an HCP. Pasting it in. Perfect. So I'm now logged in to the console UI. So let's explore this for a second. We logged in with the ACL because it's secured by default. So let's take a look at our services. We're seeing a similar thing here like we saw on kubectl get pods. We have the different pods here. I want to click into API gateway to show you some of what happens with API gateway, some of the magic behind it. When API gateway gets stood up and it has the routes attached, it automatically creates these intentions here to the respective services that are behind the routes that you set up. So you'll notice that API gateway is allowed to communicate with Echo 1, Echo 2, and Nginx. And that's it. So this really establishes, stays true to the least permissive zero trust principles in here. Okay, we also have some routing here. You can see that this is basically routing correctly to the API gateway. And if you go into the different services, you can check out how that's working as well and how your routes are set up to the various services. So let's now move back to VS Code. And what I want to do now is I want to let's clear this out. Let's do kubectl get services. And so when the API gateway gets stood up and the routes are attached, a load balancer is created in your cloud provider. Now, this load balancer is essentially what allows ingress from the outside into your service mesh. Okay, so I'm going to grab that DNS name, and I'm going to open up a new tab here, and we're going to go to /echo. And here you can see this is the Echo service. I'm going to make it a little larger. I'm going to make it, if you take a look at this host name here, this is Echo 1. This is what we're seeing right now. This is one of the services. But if you remember, we had Echo 1 and Echo 2 behind the route right here. It's a load balance thing. And it's a 50% chance whether we're going to get routed to Echo 1 or Echo 2. So I'm going to just refresh this a few times. Okay, and here's the coin toss that sent me to Echo 2. And so you'll notice that this is successfully load balancing between the two pods. The second one I want to show you is HashiCorp, which is the micro service application. And so we have that same DNS name /HashiCorp. And here it is. This is HashiCorp. And so now we can explore this application and the different interactions you do on here. Go to different components of the microservices architecture, to payments, to sign-in names, and you can explore that in the architecture diagram. So that's it. That's the two ingress components there. Again, you can check this out in our tutorial that we have linked. All the details are in there. So you'll see familiar diagrams that you saw throughout this presentation in terms of the architecture. And we also have a great documentation. So this is our learn and guided tutorial area. We also have Consul.io, and there's a ton of docs here on Consul API Gateway and the different kinds of configuration details that you need to build it for your specific environment.
Okay, thank you, Eddie. That was super interesting. Do you think we have time for like a couple of questions that came out?
Absolutely. Yeah. Just that sounds great. Let's move into questions.
So the first one that seemed like to ring a bell to me is like, okay, you showed this configuration that seems like very easy to achieve, but it seems that you applied this configuration to a freshly built cluster or Consul data center. Is API Gateway something that can be installed and applied to an already existing Consul data center?
Yeah, that's a good question. So yeah, the tutorial is built around a new environment, and it's easy to stand a lot of stuff up in a demo or new environment to get an idea of what's going on. In this case, yes, it is absolutely easy to add to your current environment. Consul, the install can easily be updated. The API Gateway components can be updated in your Helm chart. So if you already have a Helm chart, which you most likely do if you have a Consul installation, it's the easiest way to install and manage Consul. If you have that Helm chart, you can edit it to add the API Gateway components. The docs pages and the learn page have more about specific configuration option. So you would just need to modify that, the appropriate values for your environment. Just make sure you always test out any new configurations in your dev environment first before deploying them.
Yes, you can never be too careful.
Right, exactly, yeah. Please.
And then like on that same line, okay, I'm all sold. I want to try the API Gateway, but then like now I'm a bit confused. We mentioned several times gateways in the Consul run. We have ingress gateway, terminating gateways, mesh gateways, now API gateways. How does API Gateway stands out? What's the difference from API Gateway and the rest?
Yeah, no, we have a lot of gateways. So I understand how it can get confusing. Gateways at the core are all about like connectivity between in and out of your service mesh in many ways. So the API Gateway, this one here, is an enhancement to the existing ingress gateway.
Okay.
In addition to like, so it's an enhancement in the way that, so it's still like about north-south traffic, into your service mesh, but it adds SSL security, it adds traffic shaping, and there's plans for identity-aware capabilities with auth-C and auth-in. So it's a true identity, it's identity and secure ingress into the gateway. Whereas mesh gateways, they're about service-to-service communication between your Consul data centers within the service mesh. Seen a lot in like WAN connections, and terminating gateways enable connectivity from services in your Consul service mesh to services outside your service mesh. And if it gets, I know it's a lot, so if it gets confusing, if you just go to our docs page and type in gateways, it'll also break down this right here, because yeah.
So to summarize, that API gateways and ingress gateways with superpowers.
Yeah, exactly. Yeah, well said. Well
then, thank you very much. It was super interesting. I don't think we have any other question to emerge.
Great. Yeah, then let's close it out. Yeah, guys, that's our show for Consul Learn Labs today. Daniele, thank you so much.
And thank you, Eddie, and thank you everybody for attending. I hope you found something interesting today with us.
Absolutely. Please check out the docs, check out the tutorial, and then also there's a survey link that we'll send out to. Please fill that out. We really want to hear from you, what you'd like more of, less of, what you're building, whatever's on your mind today. Just feel free to put it in that survey link because your feedback is essential to how we grow and how we operate here. So thank you. And have a great learning journey ahead.
Ciao.
Ciao.
Thank you, guys. That's it for today.
Okay, we're offline, I guess.
Sorry?
We are offline now.
You're offline, yes.
Okay.
The bumper is going directly on stream one, so you don't see the outro bumper. So we're offline, so we're completely done. Thank you very much.
Good. Thank you for your assistance. Very nice. And I don't know where wait, that did. And somebody take a screenshot of this.
Oh, no, right there. Here, hold on. I'll take a screenshot. Hold on.
I'm not able to move like specular.
Got it. Nice. That was fun. You did great, man. Seriously.
And we were like perfectly on time. That was amazingly managed.
Yeah, that's very good. That's very good. Thank you very much. Until next time.
Yes.
Thanks,
Ciao.
Ciao.